This is kind of interesting how they're using the actual aluminum heatsink plates also as the current carrying material. So they're bridging with this little bracket here. They're bridging this one to this one, and then this is where the power goes out, and then it's bridged to this one. So you've got these three plates are common to each other. And then on the other side, back here, this is where the other connector, the other wire goes. And that one, they're using that. The anode of this diode goes to that. The anode of that diode goes to that. So you can see the anode and the cathodes are split. So that's how you're getting your negative on one side and your positive on the other side for your DC arc welding. And then I'm assuming there must be some switching going on so you can reverse. Well, no, this doesn't have a polarity reversing switch like my other unit does. Oh, no it does, right there. So that's your polarity reversing switch. So that's just going to be a big set of contacts in there that allows you to switch whether or not the output lead here is positive or negative. So basically this lead right here goes down to the transformer. This is your AC coming in to the rectifier, and then this wire coming out right here is going to be off of half of these diodes, cathodes, and then let's see. Oh, actually, no, that's not how they're doing it either. That's interesting. I would have thought there would be another wire here, but there isn't. I'm not quite sure. I'm sure the schematic would probably tell me. Alright, so now I got that whole bank of rectifiers out of there, and I'll take that apart further, because I'm going to end up, I'll test those diodes, and I'll save any ones that test good, and I'll take those aluminum plates, and I'll throw them in the scrap / project metal pile in case I need something like that. That's got a lot of holes in it though, but you never know, I might need a piece of plate. And meanwhile, now you can really see this transformer. The thing's massive. I mean, the thing's probably, it's roughly about 2 foot square, close to it anyways. A lot of copper in that. A lot of steel too. A lot of the weight is the core. If I wanted to take the time and try and separate some of this copper winding from the cores, I could get more money for the copper. But that's a much bigger job than it looks. So I'm not going to tackle that. What I'm wondering about is I'm wondering how this transformer is attached. That almost looks like it's welded to the frame. Huh. Well, I was able to get this contactor off, and that 1 3/4 is the size, I guess. It actually says the rating is on single phase on 208 to 230 volts, 5 horsepower. So I could start an up to 5 horsepower motor on single phase 220. And for 3 phase, 10 horsepower. And then 3 phase 400 volt, which obviously I don't have, 15 horsepower. So if you had to buy that contactor, it'd be pretty expensive. And I don't even know if it's any good, but we'll save it and maybe find a use for it down the road. I started to take these relays off, and I realized this whole plate right here can come out. It'll be a lot easier to deal with taking this apart, taking these parts off once I have this out. Oh, looks Looks like most of these connectors right here are push-on 1/4-inch spade type, so don't even need to unscrew them. Oh, fell to the fuse. I'm not going to bother taking all of this apart right now. I'm just going to store it the way it is. But I am going to keep this terminal strip. These are handy to have. Heck, I think I'll even save this grommet. It's not all dry rotted like I thought it would be. More sheet metal scrap. And I just undid this outlet. I'll end up saving that just in case I need an outlet. The other one proves to be worn. Save these front panel switches. These are all basically, it looks like they're double pole, single throw switches. And they all appear to be just held in by the these nuts on the front, which is a common way for smaller toggle switches to be held in, even though some of these are kind of big. This one isn't. This one is just basically in the control circuit to determine whether or not you're using a remote amperage pedal or the front mounted one. I just dropped the nut out. There it is. Push on spade plug connectors, 1/4-inch again on that. Same thing with the outlet. These are a lot easier to take off with pliers. That's just a little jumper. Throw that jumper back on there just in case. On the main power switch, that's a bit heftier. That is a 20 amp, 250 volt AC switch. Toggle switch. Certainly wouldn't want to have to buy one of those if I had to. Well, I know I definitely want to keep this rheostat if it's good. And I think until I'm sure that all the contacts are good in the other machine, I think I should probably keep this assembly here that changes the ranges. Basically selects the different taps on the transformer. Even if this doesn't have the same exact layout as the one that I have now, maybe I can see these contacts actually look like they unscrew and can be replaced. So if that's the case, I might be able to replace any badly worn ones with some of the less worn ones in here. I wouldn't be surprised at all if some of these have a lot more wear on them than others. Because if the unit wasn't, if this range switch wasn't rotated a lot, if they kept this basically and did the bulk of their work in a certain range, then some of those contacts are going to have very little wear on them. Now rather than take this all apart, I could take this bracket right here, unbolt it from the front, undo just some of the wiring, and I can take this whole thing out as a unit. Keep it that way for now. But before that can happen, I've got to get this knob off, and there are actually two holes in the knob here that I could see an Allen screw through. Allen screw through. Alright, I loosened the bracket, confirmed that, yeah, that's going to come off as one assembly, but I've got to get some of these cables disconnected. Alright, that's almost all the wires now off of this thing, except for these here on the rheostat, which are soldered on. I guess they really wanted to make sure that stayed connected. And the ones on this selenium rectifier, that's out. Well, it appears to me that they intended, if you had to replace these contacts, they intended you to replace this whole red part right here as an assembly. Because although these bolts that attach the wires to the contacts partially hold them in, they're also riveted in right here with either copper or brass rivets. But if I did have to replace just one of these on my other one with one of the ones off of here, I don't see any reason why I couldn't drill out the rivets and then put new rivets in. Not even sure that I would have to necessarily use, well, I'm assuming they used brass or copper rivets because they didn't want to use a dissimilar metal here to cause some kind of a galvanic reaction type of corrosion issue. What's that say? 200 ALA 32. Well, it's 200 amps, right? I wonder what the 32 is for. This is a cam mechanism here that is responsible for what keeps this locked into its selected position. Oops. Yeah. Tip for you: don't get dirt on your rheostats. A lot easier for me to get this center outlet out now. Let's see if I can't get this board assembly out of here that has this big, it's got this little transformer and this big inductor on it. It appears to be bolted to the top here to some standoffs. Those bolts aren't visible from the front. Oh, it looks like they'll come out somehow. This is the board that has those capacitors on it that leak. I gotta believe there's a way to access this from the front. Well, I'll take that back, maybe not. So if we check under the hood here, you can see only the bottom half of the board. The rest of it's kind of up underneath there. It appears to be behind this. This appears to be able to come out somehow. Right here, this looks like it might separate from the main units. So, I'm looking from the back side, and I see this looks like brackets that are actually holding up the actual polarity switch unit itself. But see these right here? I'm thinking those are what that metal cover might actually hinge on. So I'm going to loosen those up and see what happens. Well, this can't come out if this lever's in there. Oh, that knob just screws on. Alright, so maybe if I undo these brackets right here on both sides, maybe I can drop that polarity switching mechanism down out of the way, which might allow this front cover and hinge to come off. Alright. Now I think I'm wrong about that, because the heads for the nuts that the bolts right here, I can reach the nuts, and the heads are actually behind the thing I'm trying to remove. So now I took out that long bolt that I thought was a pivot bolt. I took that out completely, and I can actually lift up on this front. So I'm going to take this one completely out on this side. I guess theoretically I could do this on the other one if I had to, by reaching in from the side here. Still kind of tricky. Or up underneath. Yeah, up underneath, reach under there. Ow.